So hello Year 10, and I hope that the write-up from last lesson went well. If you do have any problems, then please do send me an email and I'll try and get back to you as soon as possible. Today we're going to look at mass changes when the product is a gas. Remember, last time we looked at mass changes when the reactant was a gas, but this is the opposite idea. So what is the equation for today's reaction? Well, you saw this as substance X. When you heat green copper carbonate, you end up with black copper oxide and one other product. What is that other product? Hopefully you know it's carbon dioxide, and that's a gas. Now, what is the relative formula mass, the MR? Remember, MR, relative formula mass, they mean the same thing. The mass of the chemical relative to hydrogen. Calculate the MR of each species. Well, hopefully 123.5 grams per mole for the copper carbonate, 79.5 grams per mole for the copper oxide, 44 grams per mole for the carbon dioxide. This is an example of thermal decomposition. So what is thermal decomposition? Well, it's using heat to break down a reactant chemical into simpler products. And the example that we're going to use is copper carbonate being broken down into copper oxide and carbon dioxide. And this happens with many different carbonates. And in fact, there's a topic at A level on it. Here's the method for the practical. Weigh approximately 2 grams of copper carbonate and transfer it to a boiling tube. Connect the bung with tubing as to the teacher's demo. Heat the copper carbonate with a light blue flame so that it thermally decomposes. Bubble the gaseous product through lime water to prove that it is carbon dioxide. Heat until it no longer bubbles. Be very careful of suck back. Remove the tube from the lime water, then remove the heat. Allow to cool, transfer the solid to a weighing boat and reweigh. This time I'm not going to give you all of the masses, you're going to have to jot these down when you watch the video. As before, there is a write-up sheet attached to this task. You're free to use that if you want, otherwise just do it in your books. You need to give a hypothesis. What do you expect will happen during this experiment? Reaction equations and theory, we've gone through the equation, but what do you think the final mass of copper oxide product is going to be? As before, at least one hazard, the risk, high, medium or low, and a precaution that we're going to take to mitigate that risk. You'll need to know that we are starting with 2.03 grams of copper carbonate. Based on this, what do you think the mass of copper oxide product will be? Now to watch the experiment. Take notes as necessary. Okay, so in this practical, we're going to do a practical that you have done once or maybe even twice before. You probably saw this in year 9 as substance X and investigated this thermal decomposition. You may also have done it in year 8 or year 7. And we're going to look at the mass changes that occur when using copper, thank you very much, Mr. Richardson, copper carbonate. So the first thing we've got to do is we've got to weigh the copper carbonate. And we want about 2 grams of copper carbonate. Now, obviously, this is slightly toxic, so the one thing you must be careful not to do is spill any on the bench.
And yourself.
And yourself, yes.
I'll wash off in the sink when I've done
this. 2.03, that's fine. It doesn't have to be exactly 2 grams as long as we know what the mass is. And Miss Richardson now is going to rinse the harmful copper carbonate off her hands. The next thing we need to do before we start this experiment is actually weigh the Pyrex boiling tube. And for that, we're going to use a plastic beaker to help us weigh it. So putting the plastic beaker onto the balance and setting that to 0. Miss Richardson can now weigh the Pyrex tube. And again, Manny's the student who's got to the end of this experiment and forgotten that crucial weighing at the beginning. So 2 grams of copper carbonate, the Pyrex tube alone, 41.57 grams. Now notice how this is set up. We've got the tube clamped near the top. We've got the Bunsen and the heat-proof mat over the base of the clamp stand for stability. Just to make sure that this setup is as stable as it can be. We need to make sure that our delivery tube will reach from the Pyrex tube that we're heating into the other tube. So there we go, that setup is absolutely fine. And now Miss Richardson is going to put her 2 grams of copper carbonate into the Pyrex tube, and then she's going to fill the other tube about 1/3 full with lime water. Now lime water, as you know, is the test for carbon dioxide. You may have gathered by now that lime water is calcium hydroxide. Okay, so we've got our 2 grams of calcium carbonate in there. About lime water, yep, about 1/3 full there, beautifully modelled.
Yep. There we go.
Lime water is slightly alkaline, so you do need to be careful with that as well. And then we will set this up. Now, lest any of you get worried that this tube appears to be blocked at the end, this tube actually has what's called a Bunsen valve in it. And the idea of the Bunsen valve, wherever it's gone.
Oh, it's here. There's the split.
There's the split. There you go. Is that it lets gas out, but it doesn't let liquid back into the tube. And that's going to be important later. Okay, so this setup looks good to me. The tube is in the lime water. We've got the copper carbonate in the Pyrex tube, and we're going to start heating. Now, we need to start heating very, very gently. So Ms. Richardson is going to use a barely blue flame, and from quite a distance, just initially tickling the powder, just to check how much it bubbles and bounces around. Because once this starts decomposing, it looks like it's boiling. So we're being very gentle at the start. Okay, and we can see the first few bubbles starting to come out there now. Okay. Now we're starting to heat it a bit more strongly now. So still with a just blue flame.
I've opened the collar about 1/3.
Okay. And it's still not looking too twitchy, which is good.
More bubbles are coming through.
More bubbles coming through in the lime water down there. And we can start to see a colour change as well going on here. You might just be able to see a blackening around the edges. Okay, this is where it's starting to go, and this is where we've just got to make sure that it's not going to bump some of the solid all the way out through this tube at the top. I'm sure many of you have seen delivery tubes that are caked in black solid, and that is from students who are a little bit too excitable with their heating in this practical. We've got a steady stream of bubbles now down here. There we go. So that's starting to jump quite a lot now. but due to the control of the flame here, it's not too bad. You can see that the jumping that the powder's doing.
You can hear the bubbling of the gas as well.
And actually, I can see at the top it's starting to go cloudy. But we'll keep heating it a bit more. Okay, you can probably open it up a bit more now, Miss Richardson. Bit stronger flame, possibly. There we go. Now we can see it's really okay. So there we go. That's what we're trying to avoid too much of. So that was great control there. Definitely going cloudy now, so we definitely know carbon dioxide being given off by this reaction. Steady stream of gas being given off now, definitely gone cloudy. I don't think anyone could disagree with that. And just as the reaction is progressing, we can open up the Bunsen more and more, just being very careful. And if it starts to get a little bit excited, just pulling the heat back away.
Oh. There's some liquid.
Some liquid? Yeah, I think that's condensation rather than anything being sucked back up.
I can't see a lot of green left.
It's all right. While there's still gas coming out the other side, we know that we haven't quite finished heating it. Is that on a fully open flame now? Okay. Okay, there we go. So we're just going to really heat it now, just to absolutely make sure that everything has reacted.
Yeah, there's still some activity in there.
Yeah, still some activity, absolutely.
It's definitely gone blacker than it was.
Yep. Nice green powder at the start, now gone black. Very, very cloudy lime water. So we don't need to worry about that anymore. Other than with suck back. So we're removing the tube first.
The tube before we remove the heat, so that is out of the way, and then we can remove our heat and turn our Bunsen burner off.
And let everything cool down. Okay, so things have cooled down. Miss Richardson can now touch the tube. It has been a good 10 minutes, which is why she was gripping, which is why she felt able to grab the tube. But even then, notice how she tapped it before she grabbed the thing wholeheartedly. We've got our beaker back on our balance. If you remember, the initial weight was 41.57 grams, plus the 2.03 grams of copper. Carbonate would have made 43.60 grams. So we can see a substantial decrease in mass here, having lost about 0.46 grams. Thank you very much, Miss Richardson.
No worries.
Thank you very much, Mr. Reeves.
It's my pleasure.
Okay, now you've watched that, hopefully you've jotted down all of the numbers you need. Here's some questions you need to answer. Was there an increase or decrease in mass, and why? What was the result of bubbling the gas through lime water, and what did that prove? A very common question, how could you ensure that the reaction was complete? It's similar to the ideas you saw for magnesium, but how did you make sure that the reaction had finished? In this case, did the final mass of product agree with your predictions from the balanced chemical equation? And if not, why might the change in mass be less than expected? See if you can come up with 2 or even 3 reasons why you might have got a smaller change in mass than you predicted. Here's the second page of the write-up document. It's got a space for your method, it's got a space for all your results, and then a space for those questions. That should take you the rest of the lesson. Please do email me if you have any problems, and I'll see you after half term.